Okay, so in this particular question, we've been presented with a situation where we've got a beaker of ammonia, and this ammonia solution, we've been given the volume, and we've been given the number of moles of the dissolved ammonia, and we've been asked to calculate the concentration of ammonia in this given solution, and to give our answer to 3 decimal places when necessary. Now, in order to kind of approach this question, one of the first things I'm going to do is establish the equation we're going to need to use for this question. So what we're going to need to be looking at is the moles. So moles equals the concentration, and that's going to be in moles per dm cubed, so dm to the minus 3 multiplied by the volume, and that's going to be in dm cubed. Now, based on this, and knowing that we need to work out what the concentration is, one of the things I'm going to do is actually, well, before we actually rearrange this equation, let's ask ourselves, well, do we need the periodic table to solve this question? Well, in this case, what we might be trying to use the periodic table for is to work out the number of moles, right, to get to the concentration. However, in this particular case, we've actually been told what the moles are in the question. So actually, in this case, we do not actually need the periodic table to solve this question. What we do need to do, however, is if you look carefully at the units in the question of where the volume is provided, you can see that the units are in the cm³, whereas our formula we've got here is in dm³, right? Which potentially poses some problems if we don't convert that to what we need. Now, if we just quickly take our attention to what the formula is when we're converting cm³ to dm³, we know that typically speaking, if a value is of a particular volume value is in cm³, it's going to be a smaller number when we change the units to dm³, right? And that's going to be by a factor of 1,000. Now, if we actually represent that, is effectively the volume in dm³ equals the volume, I'm just going to use V, the volume in cm³ divided by 1,000. Okay, so therefore what I can do with this equation is that I can effectively substitute this value in for where we've got the volume stated here, right? So we can substitute that in, and if we do that substitution, what we get is that the moles is equal to the concentration in moles per dm³ multiplied by the volume in cm³ divided by 1,000. Okay. Now, from this point, we do need to work out the concentration, right? So that is the main focus. In order to rearrange this to get to the concentration, we're going to do 2 operations, and I'm going to do this kind of at once. We want to first of all multiply both sides by 1,000. So what we're trying to do is make concentration a subject. So we're going to multiply both sides by 1,000. Okay, so 1,000 times, and if we multiply that side by 1,000, you'll quite clearly see that this leads to effectively cancels out to 1. Okay, and what we're also going to do is divide both sides by the volume. Okay, so if we divide both sides by the volume, we're going to get that divided by the volume in cm³. And if we do the same over here, divided by the volume in cm³, of course what we get is that this is going to effectively cancel out, right, to 1. Therefore, what we're left with is, and I'm going to put the concentration on the left hand side. So concentration in moles per dm³, so in moles per dm³, right, is equal to 1000. So I'm just writing this out, okay, 1000 multiplied by the moles divided by the volume, okay, in cm³. Okay, so we have all of those values provided in our question. So all we really need to do at this stage is effectively plug those values into the equation which we formed. So then we're going to get that is equal to 1000 multiplied by 0.03. Then all of that is going to be divided by the volume, which, as you can see here, is 104. Right, and if you have a go at that on your calculator and see what that comes to, you should find that the answer you get is 0.2884 Okay, now our question actually specifies that we do need to give our answer to 3 decimal places, right? And in this case, we can see we're going to need to round this. So this would be equal to 0.288, right? Here's the thing. In this case, the other thing which we're going to need to do is we do also need to add the units. Okay, so to get our final answer is going to be 0.288 moles per dm³. Right, so that would be our answer. Okay,